Hello, my wonderful Advanced Algebra students. Let us take a look at a few problems from your Section 5.4 worksheet, Factoring and Solving Polynomial Equations. We'll start first with problem number 13. Problem number 13 says 125n cubed plus 216. This is a sum of cubes problem. Let's remember the sum of cubes formula listed up and to the right on your screen. A cubed plus b cubed equals the quantity a plus b times the quantity a squared minus ab plus b squared. Our first step is to identify a and b. A and b must be perfect cube roots. We notice that our first term is 125n cubed. The cube root of 125n cubed is 5n. The cube root of 125 is 5. The cube root of n cubed is n. For b, we must take the cube root of 216. The cube root of 216 is 6. We have now identified our a and our b. Let's go ahead and plug these into the formula. We have a plus b. That is simply 5n plus 6. In the second set of parentheses, we have a squared. That is 5n squared. 5n quantity squared, which is 25n squared. Minus AB, 5n times 6, which is 30n, plus b squared. 6 squared is 36. That is our answer. The most important part of doing this problem is to determine a and b. Let us move to our next problem. We will take a look at problem number 20. This is a factoring by grouping problem. In order to factor by grouping, we are going to factor the same thing out of the first two terms. And then we are going to factor the same thing out of the second two terms. In the first two terms, our common factor is n squared. Let us put n squared on the outside of a set of parentheses. This is reverse distribution. We must find out what is left inside. N squared times what gives us n cubed. That value is n. N squared times what gives us 5n squared, positive 5. Let us do the same thing for the second two. We can factor out a negative 9. What is left is n plus 5. Our goal is to get both sets of parentheses having the same quantity. We want to factor out a negative 9, because if we only factor out a positive 9, we would not get the same thing in the second set of parentheses as we do in the first. We are now going to factor again. Please note that n plus 5 is the same in the first term as it is in the second. Let us factor that out. N plus 5 will be factored out on the outside. What is left over is n squared from the first term and negative 9 from the second term. After we have factored like this and factoring by grouping, we must take a look at both things that are in parentheses and determine if they can be factored again. The n plus 5 cannot. It is as simple as it gets. However, the n squared minus 9 is a difference of squares, and it can be factored into two sets of parentheses, both starting with n, both ending with 3, one of them positive while the other one is negative. We now have three sets of parentheses, and that is our final answer. Remember that we are not always guaranteed that either one of the two sets of parentheses that we got at this step here can actually be factored further. Let's move on to a third problem. Problem number 26. This is factoring polynomials that are in quadratic form. What we will notice is that this looks like it is in quadratic form. It has three terms with a constant at the far right hand side. However, we actually need a quadratic term at the beginning. We do not have that. We need a linear term as our second term. With a simple substitution, y equals s squared, we can go ahead and substitute into this and get a quadratic. If y equals s squared, then squaring both sides gives us that y squared equals s squared squared, or s to the fourth. We now use these to substitute into our original polynomial. S to the fourth, as we see, is y squared. Let us rewrite with that substitution. 3y squared. S squared, as we noted, is just y. And so this polynomial turns into a quadratic 3y squared minus y minus 24. It's now our job to factor this. This is one of the more complicated quadratics to factor, as it has a 3 at the beginning. That means that we need to have a 3y and a y at the beginnings. We then must come up with two things that multiply to be 24 that we can put in here. This is a guess and check problem. We will use 8 and 3. Put 8 in the beginning slot, 3 at the end, and then we need to place both a positive and a negative in here, since we have a negative 24 at the end. Positive 8, negative 3 will work. Using FOIL to check, this is 3y squared. Outside is minus 9y. Inside is positive 8y. And last is minus 24. Our two middle terms, the outside and the inside, check. That makes negative y. We can now substitute back, as we need to have s squareds in our final answer. Y is s squared, so the first set of parentheses is 3s squared plus 8. Our second set of parentheses is just s squared minus 3. We check to see if these can be factored further. They cannot. We have a sum in the first set of parentheses, and we do have a difference in the second set. However, it is not a difference of squares. This 3 is not a perfect square. This is our final answer. And those are three problems, one of each type, that we have encountered on the Section 5.4 worksheet. You should now work similar problems to these elsewhere on your worksheet. Thank you.